Let's talk for a minute about similar triangles and similar polygons. There's just a little bit that we need to know in order to be able to solve problems if we are asked if they're similar or if we're told that they're similar. So for similar triangles and for polygons, the main idea is that all your angles are congruent, or you can solve to see that they are all congruent, like you're given enough information to conclude that. And then you have corresponding angles have the same proportion. So in my example I drew here, I have triangle ABC is similar to triangle DEF. That would mean that angle A is congruent to angle D. Notice they have one of those angle markings. Angle B is congruent to angle E. They have two of the little congruent angle marks. Angle C is congruent to angle F. So that was given to me, or you'd be able to figure that out with the problem you're given. And then side AB is proportional to DE. Notice it's the side between the single and the double angle marking. So sometimes the figures can be turned sideways and you just got to be careful. This is just a pretty direct example to start with. So AB is proportional to DE in the same proportion that BC would go with EF, because that's the side between the 2 and the 3. So if your figure is turned sideways, you'd be able to pick it out somehow. And then the base, so AC would be proportionate to DF. And the important thing is that they have the same proportion on all the sides. You can conclude that they're similar if you have at least two sides to compare. But if you have all three, then they all three need to have the same proportion. And for this example, it was 6 over 12, 7 over 14, and 10 over 20 when I just plugged in the values from the example. And then you can see that it has a ratio of 1 to 2. So each one of those comparative sides had the same ratio, and we call that the scale factor. So let's look at one more board just to look at some polygons that follow that same policy. If you have all angles are congruent, you're checking to see if the sides have the same proportion. And so for this example, I have two rectangles and I set 20 over 30. So notice they're just giving me, looks like the width of the rectangle. Or you can go by the smaller one compared to the smaller side. Is that the same proportion as the larger side compared to this larger side, or the length it looks like of our rectangle? So 20 over 30 does have the same proportion as 36 over 54. And so it was a scale factor of 2 to 3 when you just simplify it. And then this one was another good example of two trapezoids. One is turned upside down, and one is considered, I guess, right side up, because we normally look at them this way. But just to show you an example of one that's not always turned so they're easy to look at. So you'd want to pick out, like, the base angles are the ones on this longer side, so they're congruent to these base angles, and then those are congruent to those. So all of our angles are congruent in each figure. And then you check to see if the sides have the same proportion. You only have to have two sides to compare, but if they give you all the sides, it's good to check all sides that compare. So these are both 6 and those are both 8. You don't have to do that twice. Let's just set 6 over 8 equals 12 over 16. And then is that equal to 7.5 over 10? And they did all have the same ratio, which was 0.75, or 3 over 4 would be our scale factor. So if you're given problems to solve, like we're going to work on in class, you would check to see are all the angles congruent and are at least two sides proportional. But if they give you more, check to make sure all of them have the same proportion, because they could try to trick you on one other side that's not quite the same. And then you could find missing values. So like if 8 right here were an x, we could use that proportion and cross multiply to figure out what number would have had to go there. Especially if they tell you they're similar, you would use these properties to figure out missing variables.